So, first thing we're going to do is do you remember the last thing we did? It was a week ago. Do you remember? We did a little bit of review from, I gave you a review packet, and we did an old quiz that was in there. Well, now we're going to do some more review, because next class, which is that Thursday, we're going to have a quiz, because we got to get ourselves ready for a test next week. Okay? So I want you to do this. This is an old quiz I made, and we're going to use it as kind of a model, although I'll make one adjustment to it. You guys got it? All right, everybody got one? All right, here we go. Let's dig. Hey. We are going to dig the cobwebs out and see what we can remember. So we're going to write the equation for this, but it says do not multiply out. All right? It says we don't have to multiply it out. And that's good news, because remember that multiplying out is a lot of pulling, right? We're not going to do that. All right, so tell me what you know about this equation. Okay, so he has figured out we got some bounces. But before we get to that point, we need to set up some parentheses, right? Oh, thank you. Who'd you buy that from? Make sure you pay that.
Yeah, I did.
All right, how do I know I have 3 parentheses? Because there's 3 zeros. So in the parentheses will be x plus 1, x minus 1, and x minus 4. Everybody clear?
No.
Now, by looking at the graph, Joe's already seen I have a bounce at here, that factor, and I also have a bounce at this factor. That's it for the bounces, right? But this is not the answer to the question. What is missing? There's one thing missing. I don't know what that is. Remember that leading coefficient. So I'll take that other random point I have, 5, 3, and we'll plug it in. So I'm going to put 3 in for y, and 5 in for the x's. So 6. Now be careful here. 5 minus 1 is 4, but it is squared. And then 5 minus 4 is 1, squared is still 1. Are you with me? So this is all multiplied. So 3 equals 96n. And n equals 1 over 32. Okay? And then I'm going to come back up here. I'm going to put 1 over 32 in for my n, and there's my answer. I do not need to multiply it out. Thank goodness. Elijah, here, I got it in my hand. Does anybody have a question about number 1? Okay, one more time. Start by writing the parentheses, then put the powers on, then plug in the numbers, and figure out your n. Got it?
Yep.
All right, number 2. Is x minus 2 a factor of this? That's a yes or no. And then we have to explain. All right? Now, there are 2, first of all, what's it mean to be a factor?
It
it means the remainder is 0. So one option you always have is to divide. This problem will be a pain in the butt to divide, because why?
Because there's not.
There's a whole bunch of zeros in there, right? If there were only one or something, that would be a different story. But x to the 7 is pretty big, and there's a lot of empty spots. So instead of dividing, what is the other option I have? Plug in. So think of the problem as a function, and plug in the same number that you would have divided by. So what number would you put out in the box? 2. So you're going to plug in 2. So 2 to the 7, that's 128, minus 12 minus 48. You have a calculator, you can do this on a calculator. What is it, 68? So the question was, is it a factor?
No.
And the answer is no, because the remainder is 68. That number is the remainder. If you had done the division, 68 is what you would have ended up with down there.
So that would be a valid explanation is no, because the
remainder is 68. And if I'm a factor, the remainder has to be 0. So if I plug in 0, if I plug in a number and get 0, then yeah, I'm a factor. Or if I divide. Division is always an option. But sometimes it's just not very convenient. So you plug in.
You always plug in?
Always. If all you're looking for is the remainder.
Right.
Remember, in a lot of our problems, we have to divide because we're interested in what's left over. But if all you want to know is the remainder, you can always plug in. All right, write the equation of the polynomial function whose roots are these. Okay, so I have roots of -1 and 2i. -2i. Remember, imaginary or complex roots always come in pairs. So you're never going to have 2i without -2i. They always come together. Build your factors, you guys. If x equals -1 is a root, what was the factor?
X plus 1.
X plus 1. What was this factor? X minus 2i. And this one was x plus 2i. Those are your factors. And it says you got to multiply this one out. So we're going to FOIL. And we'll start our FOIL right here. It doesn't really matter, but it's easier if you start with those two. Because do you remember what happened? We did this the other day. A bunch of stuff's going to cancel. Yeah. So end up with x squared plus 2ix. These guys dropped out, right? And that's a plus 4. So we have x squared plus 4. Don't forget, you still got to multiply again by the original x plus 1. And there is my function. I believe, unless I made a mistake.
That's it.
Is that it? Okay, so what do we need to remember about that? We need to remember that imaginary roots come in pairs. And if the root is x equals 2i, the factor becomes x minus 2i. All right, next. List the possible rational roots. Tyler, pay attention, because it's come to my attention that you didn't know what PRR stood for. Possible rational roots. Don't say I wasn't here, because you know what I'm gonna say. Watch the video.
Videos.
Possible rational roots. Now, how do I find the possible rational roots? Always plus or minus. Do not forget the plus or minus. Factors of last, which is very simple, 7 and 1, over factors of first, which are 2 and 1. Now, please note, it says list them. That is not a list. So to build the list, we'll have 7 over 2, 1 over 2. Now I'm gonna put plus or minus out in front, and you're allowed to do that. Plus or minus all these options. So I have 7 over 2, and I have 1 over 2. What else do I have? 7 over 1 and 1 over 1. There's your list. All the combinations of top over bottom. That is your list. All right, number 5 you can cross off, that's Descartes' rule of signs, and we don't cover that anymore. At least not right now, so you can cross off number 5. Remember, this was an old quiz. Cross off number 5. Very old quiz. This is back when we had periods with numbers instead of letters. All right, number 6. A ball is thrown into the air, its height is given by this. When does it reach its maximum height? Now, let's just pause and not freak out because we have a word problem and then an equation that looks very hard.
Plug in the calculator.
No, you're not gonna plug it in on the calculator. Okay, absolutely, could you graph this on your calculator and do second calc math? Absolutely you could. But this one, we don't need to do that, and actually for most of you, it's gonna be easier to do it by hand. Here's why. What shape is this? If you were a parabola, it would be a parabola opening down. And the maximum is just going to be the vertex. And how do we find the vertex?
Opposite of B over 2A.
Negative B over 2A, which in this problem will be negative 32 over negative 32, or 1. So whatever this point is, its x value is 1. And then how do I find the y value? Plug it in carefully. So 1 squared is 1, negative 16 plus 32. I got 21, did you?
Yeah.
In this projectile motion formula, which we've used before, the T's obviously stand for time, and this stands for height. How high is the ball? So that is 1 second, and that is 21 feet. Whenever we are using this formula, time is in seconds and height is in feet. So what's the question? When does it reach its maximum height? 1 second. The question could have been, what is its maximum height? And then you would say 21 feet. All right? That's pretty easy. So what's the key there? This is a parabola, opening down. Maximum is vertex, negative b over 2a.
Would you ever ask, like, what's the height at 4 seconds
Sure.
or something like that?
And then you just plug in 4. This ball will be on the ground, I believe, at that point, but, yeah. All right, number 7. the cafeteria has determined that for every $1 increase in the price of salads, 100 fewer will buy salad. Currently, the salads sell for $4 each, and 1,000 students buy salad. What is the cafeteria's maximum revenue or income? So their revenue comes from the number of salads sold times the price each, right? That's how we would, if I'm the cafeteria guy, that's how I would calculate my income. Okay? How many salads am I selling?
1,000.
I start out selling 1,000. But what's happening to the 1,000?
Every dollar increase goes down.
It's going down in increments of 100? So minus 100x. X is the number of increments. Every X is worth negative 100 people. What's the price I'm selling them for? $4. And what am I doing there? That price is going up in dollar increments. Right? Now, let's just for fun, let's multiply this out. So I have 4,000 plus 1,000x, 400x, and minus 100x squared. Now, I haven't simplified it yet. What does this tell me about my equation? It's another parabola opening down, and I'm looking for a maximum. Isn't this just another vertex problem?
Yeah.
All right, so let's clean up our equation. Negative 100x squared, 600x, and 4,000. So I need my vertex, right? So x is going to equal negative b over 2a. I got 3. Did you? Now what does that 3, what is that 3? Is that, what is that? 3 what? 3 increments, right? So 3 times, I'm going to change my price. So my price is originally $4. Now it's 7. And I originally sold 1,000, but now I'm going to sell 700. The question says, what is the maximum revenue? Won't that be 700 times 7? Which is what you get when you plug 3 back into your equation. But I just did it up here because it was easier for me. Right? So what is that? $4,900? Okay? Question might have said, how much did the cafeteria charge for a salad? The answer to that would have been $7. All right, between what two consecutive integers is the positive real root of this lie? Now, we've not done this specific problem, but you guys are smart people and you can figure it out. So let's look at the polynomial. What are the possible rational roots?
6 and 1.
6, 3, 2, and 1 over 1? Right? Now the question tells me, implies anyway, that there's only one positive real root. So in other words, there's only one of these numbers that works, okay? So to save time, here's my function. I'm gonna have you guys over there, Tyler, Jaden, you guys over there. I want you to plug in 1 to the problem. Charlie and Elijah and all you guys in that row, I want you to plug in 3. You guys over here plug in 2. And I'll take the easy one, I'll plug in 1. Oh, wait. Wait, did you guys plug in 1? Oh. Alright, I'll have to plug in 6 then. I'll plug in 6. Alright, what'd you guys get, Charlie?
It's 33.
Alright, you simply put in 3.
My bad, I got 33. I was taking my time. I got 33.
You're not focusing is what you're not doing. Pay attention. Alright, what did you guys get?
33.
33. What did you guys get? 10. 10? Okay, now, what does this tell me? Remember what we talked about earlier? When you plug a number in, what are you looking for?
0.
You want to get 0. So this tells me that none of those numbers is a root. Would you agree with that? Okay, well the question kind of implied that because the question said, where does the root lie? I want you to look at these outcomes here. When you put in 2, you got 10. But when I put in 1, I got -1. What number am I looking for? 0. Isn't 0 in between these two?
Yeah.
So between what 2 numbers will my 0 be? Between 1 and 2. Between 1 and 2. Graphically, this is a point. This says if x is 2, y is 10. This says if x is 1, y is -1. And then of course we have these two, 3, 33 and 6, 234, right? But what happens when I connect those 2 dots? Isn't there gonna be a 0 in there? Isn't that point right there something, 0?
Yep.
So between what 2 x's will the y have to be 0? Between 1 and 2. If you had typed in this number, let's say f of 6 was -5, then wouldn't there have to be a 0 in there somewhere? Because we went from being positive to being negative. And if you go from positive to negative, these are all connected. So if you go from positive to negative, don't you have to cross 0?
Yep.
And it would be crossing in between those. Does that make sense? Yeah,
Do you just
yeah.
put 2?
So this was not right. That was something different. So the answer to the question would be somewhere between 1 and 2.
How do you mark that?
You would just say somewhere between 1 and 2. And if you had to guess, do you think it's closer to 1 or closer to 2? 1, because that number is closer to 0. Back in the old days, before we had graphic calculators, we had to actually, if we wanted to find the 0, we wanted to find the point where it crossed, we actually had to do, okay, what's 1.1? What's 1.2? What's 1.3? We actually had to evaluate all those to get as close to 0. All you guys have to do is tell me it's between 1 and 2. Okay? Tomorrow, or Thursday, we have a quiz. It will have problems on it like these, except for number 5. That is not on there. Don't worry about number 5.
Thursday?
Whenever I see you again, I think it's Thursday.
Yes, it is. I'll just make sure. Yeah.
It's our next class, okay?
Alright, wait.
Now, what I need for you to do now is get out that review sheet, that packet, 2 sheets stapled together that I gave you last time. And let's pick a good review sheet. Let's pick the one that says review number 2. Precal A period 5 is the best, review number 2. So it's a 2-page review sheet. All right, ready? I don't know if I do, they're back there in the black crate. Okay. So here we go. Number 1. Write the, oh, this is good practice for our quiz. Write the equation of the polynomial whose roots are 3 and 5i. So stop. Ronan, if 5i is a root, what do I automatically know?
Negative 5i.
Negative 5i. And then, Jaden, what are my factors? What do you mean you don't know? Yes, you do. Just pick one of these. Somebody jump started. What are my factors? X minus 3, X minus 5i, X plus 5i. Pay attention. Now I gotta multiply it out. It doesn't say to, but it doesn't say not to, so I'm gonna multiply it out. Here we go. Where do I start? These guys, right? So x squared. You know, some things are going to cancel, which makes us very happy. And these are gone, and what's negative 25i squared? So x squared plus 25 is what I have for these, which then I times by x minus 3, so it's another FOIL. We want our answer to be in descending order, so if it doesn't come out that way, you'll want to rewrite it so that the powers are going down. Jillian, you want to come up here? Would that help you so you're not having to crane your neck? All right, you got it?
You just put a Y in front of it.
Yep. I'll put another X in front of it, but it doesn't matter, Y will be fine. Where's your polynomial function? Number 2. F of 1 is 3, and F of 3 is negative 1. Write the equation of the linear function. Now, when you hear that word linear, you're immediately thinking line? Line? And when you think line, you know I gotta have the slope. So slope requires 2 points. What are my points? 1, 3, and 3, negative 1. Don't mix those up. Function notation is f of x. Whatever's in that parentheses is an x. Right? So slope, here we go. -1 minus 3 over 3 minus 1. I got -2, but I could have done something wrong. Is that all right? Then what?
Now you gotta find points to.
Find a point, I'll use this one. Y minus 3 equals -2 x minus 1. Now, because the directions stipulate linear function, I'm gonna have my answer be f of x equals, because it says, write a function. F of x is the same as y, so I need to get y by itself. So I'll distribute, and I got -2x plus 5. Is that okay with everybody? Got it? All right, number 3. Is 3 an upper bound? Explain. All right, we haven't done this, talked about this in a while. How am I going to decide? What am I going to do? I'm not gonna plug it in.
You
This
can find the
is-
word.
No,
Do,
this time I actually have to divide. This time I need to actually divide. So what's gonna go in the box? 3. Watch it, watch it. You have a 0. You gotta have your eyes open, folks. How do I know I have a 0?
you're missing an X.
I'm missing an x squared. Right? So here we go. Let's divide and see what happens. Remember, the 2 comes straight down.
Yes.
All right, if I did my division, all right, double check my numbers there, make sure. It's so easy to make a mistake in that process. Does that look okay?
They're all the same, they're all positive.
They're all positive. And when you do the division, and that row turns out all positive, then you have found an upper bound. And if you were in one of those problems where you had to be guessing numbers to try to get 0, you would not guess anything higher than 3. 3 is an upper bound. No number bigger than 3 is going to work. So you would concentrate on numbers less.
How do you split it?
In the division, all of the signs, all of the numbers were positive for the quotient and remainder. This is your quotient and remainder. All the numbers were positive. If you had divided and this happened,
That's negative.
then you know you would have a lower bound. Because the signs in the quotient and the remainder alternate. Everybody okay? Another quiz question. List the possible rational roots. So my PRRs are going to be factors of 6 over factors of 2. So when I list these, I'm going to go ahead and do 6, 3, 2, and 1. Because that's 6 over 1, 3 over 1, 2 over 1, and 1 over 1. Now I have to do 6 over 2, but I already have it. 3 over 2, 2 over 2, already have it, and 1 over 2. So there is the list, plus or minus all of those numbers. Did you follow that? It's a quiz question.
Could you just list like 6 over 2 even? Like I know like
No,
there's a
because you would
variation.
reduce it to 3, and 3 is already in your list.
Oh, that makes sense.
Yeah. x1 a factor. You have two options. What's one option?
Plug it in.
Plug in. What would I
Negative
plug
one.
in?
Negative
Negative 1. So if I plug in negative 1, I get negative 2 minus 8 minus 9 minus 6. If I plug in negative 1,
25.
negative 25. What's the answer to the question?
No.
No, because it didn't work out to equal 0. What is your other option? That is an option. That is definitely an option. What's another option?
Divide.
To divide. And if you divide, you would be dividing by the same number you plugged in, negative 1. And we have 2, negative 8, 9, negative 6. And what's going to happen is, look, what did the remainder turn out to be? Same thing, just so we knew it would be negative 25. So either way you do it, the answer is going to be no. And the reason is going to be because the remainder wasn't 0. Everybody good? All right, solve. Yeah, okay, let's solve. Here we go. What do you think about this? Solve means find the roots.
You can group it.
You can group it. If you notice that, that is always going to be your fastest option. If you can group it, grouping is going to be your fastest option. Not your only option, but your fastest. So take out an x squared, x plus 3. Take out a negative 4, x plus 3. Everybody okay to this point? I want everybody to be where I'm at here because then I want your complete total attention because some of us are messing this up. Everybody good to this point? Notice you have a match. X plus 3, that's the key. You gotta have a match. Write down the match. Write it one time. And then write down the leftover part. Then we notice that the leftover part is self-factors. So what are the zeros or the solutions for solving the equation?
Negative 3,
Negative 3,
negative 2.
negative 2, and 2, plus or minus 2. Just occurred to me, I forgot to take attendance. Looks like Caitlin, maybe is the only one missing. Okay. Jack, did you pay attention to this? I think you missed this on something, I graded it yours.
Yeah, I did.
You got it
I
now?
know
You
Yeah.
got it?
Oh.
All right. Next one. What are you gonna do with this next one? The directions says solve. Factor if I can.
Or quadratic.
Yeah, I'm not sure I can factor that. What do you think? I don't think that factors, do you?
No, it doesn't.
So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I got 92 under there. Anybody else get 92? Is it 94? I don't think it's 92. 92, okay?
Yeah.
2 break down?
4.
2, 23.
You can follow that too.
And now the 2's can come out. And there are my trinomials. Take a moment and digest that. There's a lot there, but it's easy. It's old stuff. You've done the quadratic formula a lot in your life. So problem A, the one I'm erasing right now, we did by grouping. Problem B happened to be a quadratic, so we can always use the formula on a quadratic. And then problem C, looks a lot like A, except
Can't factor.
you can't group it.
Goodbye.
So what do?
Goodbye.
We pick a number and divide. Now, what are the numbers we're going to pick? Don't just start picking
14,
random
1.
numbers.
7, 2.
Plus
You're
or
gonna
minus.
pick plus or minus 14, 7, 2, or 1.
Yep. Oh, for 1.
So, I don't care. Oh, let's use our heads here.
Yeah.
Don't we want to end up with a 0?
Yeah.
These are all positive.
We don't want 14.
All positives aren't going to ever give me 0. So don't I need to get a negative involved?
Negative 7.
-2.
Negative 7.
Negative 2. I'll try negative 2.
Negative 7.
It's negative 7. Well, I'll find out in a minute. Actually,
No.
What did I say? What did I say?
I think negative 2 works. Now, could negative 7 also work?
Yeah.
Yeah,
I didn't.
I don't know whether it does or not, but negative 2 does. So let me back up for a second. Is everybody clear about why I just kind of thought I'll use a negative number? Think about your division. If you have a positive number out here, are you ever gonna get things to cancel out and give you 0? No. So there were no negatives in the original line, so I needed to get some negatives in there. Worst case scenario, you pick a positive number, anything's gonna work. All right, where do I go from here? What am I doing? Solving. X equals negative 2 is one of my answers. Then I'm gonna look right here, and I'm gonna see that I have a little quadratic. X squared plus x plus 7. Does that factor?
No.
So guess what we're gonna do again? X equals negative b plus or minus the square root of b squared, square c. Uh-oh.
Oh.
I think I'm going to get negative 27, so I root 27. 1 minus 28. What about 27? If I want to get full credit, I gotta be simplified. 27 right down?
3.
3 root 3. I always write 3i root 3, but if you write I 3 root 3, that's fine, doesn't matter. You need a 3, an I, and a root 3 in there.
Jesus.
So the answers are negative 2, the original one we guessed, and then those two.
We don't have to write them out, do we?
No. You didn't even recognize that there's really 3 answers there. Does everybody see that? 3 answers? And that makes sense because it's an x cubed problem. And x cubes are gonna have 3 answers. All right, so let's recap that little section there. If it's quadratic, x squared, use your formula. Unless you can factor it. If you can factor it, do that. So quadratics are easy. If it's a cubic, look at A and C. What are our choices? We either factor by grouping, or we guess and divide. Right? Okay. remainder. I do not want to divide this problem because there are too many zeros. So what will I do instead? I will plug in 1. Listen, I know you guys we've been at this for a while, we're starting to get bored, can't imagine it. But we need to stay focused, okay? We need to stay focused. Because we have a test coming up. Find the remainder. I'm going to plug in the same number that I would have put in the box if I were dividing. If I were dividing, wouldn't I put a 1 in the box?
Yeah.
So I'm going to plug in 1. So 3 times 1 to the 50th, which is 1, minus 3 times 1 to the 27th, plus 10 minus 3. Did you get 7?
Yeah.
That's the remainder. The remainder is 7. We've had that problem worded 2 different ways. Is x minus 1 a factor? No, because the remainder is 7. And this time it just said find the remainder. The answer is 7.
Would it be, oh wait, never mind. I was gonna say, would it be like 7 over x minus 1?
If I were writing out the entire division, yes. It's okay. If you wrote that, it would never be wrong. But it's okay to just write 7. Are we okay? Everybody good? All right. Sketch. It's gonna be a quiz question. Gotta be able to sketch. What's the first thing I do?
Plot the zeros.
First thing I do is plot the zeros. So I'm gonna have 1 at -1,
1 at 3.
3, and -5. You good so far, Aiden? Good so far? All right. Now, the next thing I gotta do is count how many x's I have. Because the number of x's you have, called the degree of the polynomial, determines whether you start down here or you start up here. So how many x's do I have? 4.
Oh, sorry.
4 is up. The coefficient in the front of the problem is positive, so that doesn't change anything, it stays up. So I'm going to start up here. When I get to this point, I have a choice. Do I zip on through? Do I bounce off? Or do I squiggle? Well, that point came from this factor. It isn't squared. So I'm going to go right on through and connect to the next one. That point came from this factor. I'm going to go right on through and connect to that point. That came from this factor, which is squared, so it's going to bounce and head. Yep.
If the cap up front was negative, how would that change?
It would start down here.
But the last one would still end up.
No. It would start down here, pass through, bounce off. Okay? So the behavior is the same at the zeros. It's gonna bounce, it's gonna go through. This is where you get started and bounce. That would be if you have a negative coefficient. Okay, I wanna skip, I've lost track of my numbers. I guess number 9 for a second, because it's not on the quiz, but 10 is. So let's make sure we've got 10 under control. Or at least 10 could be on the quiz. It was on the practice quiz. So we'll come back and do that other one next time. But let's maybe this time, let's see. Number 10. I I got a formula, an equation.
Out of order, it's out of order.
Yeah, it's out of order. So I think I'm gonna go ahead and turn it around just for my own sanity. You don't have to, of course, but it's backwards. When does it reach its maximum height and how high does it go? Right, those two questions go together because those two questions are asking me for the vertex. X equals negative b over 2a, which is 5/2 or 2.5, if I simplify right. So which question does that answer? A. That is 2.5 seconds. At this point, 2.5 seconds, 5/2. All right? Now, how do I find the second half of the vertex? Plug in 2.5. I got 50. Anybody else get that? Anybody else get 50?
Yep.
Okay. And that's 50 what?
Feet.
50 feet. And so the answer to question B would be 50 feet. All right? Now the last question isn't on our quiz, but you should know how to do it. It says, when does the ball hit the ground? So go back to your original equation, either version of it here. And if the ball is on the ground, what do we know?
The Y is 0.
The Y is 0. So we're going to solve that equation. You can take out an 18. So the ball is on the ground at 0 and at 5. Does that make sense in any way to you?
It bounces.
Here's a picture. You told me that was at 2.5. Does it make sense that this would be at 5? Because parabolas have symmetry, and if it took it 2.5 to get up, it's going to take it 2.5 to get down. We know in reality that's not always the case because of wind and stuff, but mathematically that will always be the case. All right, I'm going to stop there, and then we'll pick up next time. So, what happens next time? Homework, I think should all be done by now. Let's get all this homework in. And I have a couple I can hand back.
Before we head into lunch, we're going to have a quick announcement. First of all, I wanted to remind you that there will be some money during the lunch period. Also, we want to wish a happy Founders Day to Kristen Marianne Stewart. Today is Founders Day for the Sisters of Health. Now let's be mindful of all of God's blessings in the name of the Father, Son, and Holy Spirit. Lord, thank you for the food before us, the Irish family and friends beside us, and the love of you. In Jesus' name we pray. Bless us, O Lord, and these our gifts, and for your boundaries, and let all those invite to our Lord. Amen.
much. My nice period.
I mean, I can't back All right, I'll see you guys next time. Have a good day. All right, how you doing, Grace? About ready?
Good, yeah.
Ready for all this?